Okay, guys, on this channel, we have been discussing the AI chip wars in detail and sanctions for months now. And over the last few weeks, I've been trying to explain at a very high level what CUDA is and the importance of it to these chip wars that have been started by the US versus the rest of the world against China, and why such figures as Jensen Huang say such things as, in order to win this, if we really want to win it, we would have the rest of the world build upon our standards, our protocols and such. Okay. And so today on Rubin Tech, where we meet at the intersection of tech, politics, and finance, we're not going to take our typical really high level where I kind of keep the details away from you because it's boring. We're going to dive in a little bit deeper and explain what CUDA is. So I would call this like a 101 to CUDA for people interested in AI chip wars. Okay, kind of a long name. And the reason I want to do that is after my last video, I noticed a lot of confusion in the comments. A lot of people were coming in, and in particular, someone tried to write a lengthy response to me, and they had an AI write it. And it was kind of funny because the AI that wrote it, of course, it wrote it so eloquently and it was structured perfectly, but it absolutely had some hallucinations in it. And I was like, this is the problem with using AI when you don't understand what you're talking about, is that when the AI says something wrong, it says it confidently. You don't know, you believe it, you go repost it. Okay. So today I'm going to explain some of these misconceptions and things that have been going on. We're going to go over CUDA. Let's stop talking about it and just hop right into it. Okay. So here we go. About CUDA. This is from the developer.nvidia.com site. This is about CUDA. Now, what is the confusion that's been happening in the comments? Well, when I talk about CUDA on this channel, a lot of times I'll say the CUDA platform, the CUDA ecosystem. I'll even say like the CUDA toolkit. And you'll hear me using this CUDA word in context with a lot of other terms. And you might be wondering, well, exactly what is CUDA? And that came into play in the comments because I was talking about, DeepSeek left Huawei and they went to CUDA because, Huawei's chips couldn't achieve what they needed to in the training of their R2 model. And in the comments, a lot of people are like, oh, they didn't use CUDA. And these people who said that, they're not wrong, but they're also not right, because they're probably software developers. And to them, when they're talking about CUDA, they're probably talking about CUDA C++, C++, which is kind of the main programming language of CUDA. Okay. But on my channel, usually when I'm talking about it, I always try to say CUDA ecosystem, CUDA platform, but sometimes I can't help it. I'll just say CUDA. But this is very important, okay, to understand exactly what it is so you know what you're talking about. And so here we come into NVIDIA and we see that CUDA is more than a programming model, okay? So for someone who says, yeah, they didn't program it in CUDA, well, that's not, CUDA isn't a programming language. It's not a programming model. It's much more than that, okay? Now, to be fair, if you are working in video games, if you have been, a developer in the gaming market for, how many ever years, to you, CUDA probably is CUDA C++. So you're like, oh, I'm going to make that in CUDA. You're talking about CUDA C++. Oh, he programmed that in CUDA. Okay, but that's not what CUDA is in its entirety. So if you don't know anything about this, you're going to understand now that some people are going to reference it like that, and they're talking about a specific part of CUDA, but that's not what I'm talking about. I'm talking about something much larger. The CUDA compute platform extends from the thousands of general purpose compute processors featured in our GPU's compute architecture, parallel computing extensions to many popular languages, powerful drop and accelerator libraries to turnkey applications and cloud-based compute appliances. CUDA extends beyond the popular CUDA toolkit and the CUDA C++ programming language. We invite you to explore the CUDA ecosystem. And really, ecosystem is the best term. Okay, so in software, we'll have like a language, you'll have around the language, you'll have SDK, you'll have toolkits. Sometimes you even have a platform like the Android platform, but then you have an ecosystem that's even much larger than that. And really, that's what CUDA is. And they're telling you right here, CUDA isn't just the toolkit. So that means it's not the compiler, it's not just the debugger. It's not just CUDA C++, which many developers call CUDA. They don't even call it CUDA C++ programming language. They just say, oh, it's CUDA. I'm programming in CUDA, right? It's not just that. It's the entire ecosystem. Okay. And in specific, I want to talk about the fact that in the comments, a lot of people were like, they didn't use CUDA, they used PTX. Well, that is true and not true. What's true is they didn't use CUDA C, C++, but they absolutely did use CUDA because PTX is a part of CUDA. So I come over here and we can say understanding PTX, the assembly language of CUDA GPU computing. Parallel thread execution, PTX, is a virtual machine instruction set architecture that has been part of CUDA from its beginning. So again, PTX is part of CUDA, right? And so you might hear this stuff and you might be like, I don't get this if you're new to this type of stuff, right? And understand that when someone writes that comment, 9 times out of 10, that's a developer who probably programs in CUDA C++, right? And so to them, that's what CUDA is. CUDA is the toolkit and CUDA is C++. Okay, so they're like, oh, they didn't use CUDA, they used PTX. But that's not what I'm referencing. That's not what Jensen is referencing, okay? The important thing isn't just the language. CUDA C++ and CUDA toolkit are extremely important. But what's important is the entire ecosystem. That is where the true power lies, is in how stretched out, wide, varied, and strong this entire ecosystem is, okay? So PTX is a part of CUDA. It is a programming language within CUDA. So to say they programmed in PTX, not CUDA, doesn't make sense. The correct statement would be they use PTX, not CUDA C, C++. Now, I'm not trying to be really technical here. I'm just explaining it so you can understand how these terms work. Okay, now PTX is a virtual machine instruction set architecture. What does that mean? Basically, all of the CUDA GPUs have different architectures. So we hear about the next architecture is Vera Rubin. The current one is Blackwell, and the prior one was Hopper. What that means is that the actual chip itself is built a little bit differently. The underlying architecture, they'll change something to improve it, okay? And what they do is they run this virtual machine on top of this of the lowest level code. The lowest level code is, for all intents and purposes, is called SAS, okay? And SAS is unique to whatever chip you're using in NVIDIA's stack. So if I got a Vera Rubin chip, the SAS would be slightly different than if I was programming for a Hopper chip. But that would be very inconvenient because then you would have to target on a chip by chip basis. So what NVIDIA has done with CUDA is they said, we're going to make this virtual machine. And maybe some of you are old enough to remember the Java virtual machine that would run on Windows and Apple, right? And so they said, hey, we'll take care of this. You don't have to worry about installing it on these different environments. It'll run on any of our chipsets, okay? And the language of that is PTX. It generates PTX binary code, which gets compiled down to SAS, okay? So why is this important? Well, because specifically what DeepSeek did, okay, is they went into CUDA and they programmed in PTX. So they went to a very low level language. Now, this is important because this is part of what people think generated this lock-in. Understand that whenever you're in development, usually the lower level you are in something, the more specific it is. Okay? However, there were some comments that said that CUDA would be portable. CUDA, and what they're talking about there is CUDA C++. CUDA C++ is not portable. Okay, it runs on a specific CUDA compiler that it does not run on anything but NVIDIA software. Okay, and so while it would be more portable than PTX, only in the sense that you probably could read the code and look at it and say, hey, something in Huawei's CAN system, CANN, is very similar, and I can kind of read this. And yes, I can't take it and directly compile it to it, but I can understand it and kind of write it over here very similarly, where I probably wouldn't be able to do that with PTX, okay? It is not in any way, shape, or form compatible or even directly transferable, okay? So I want to be very clear about that, okay? So when we look at the case with Huawei, what happened with DeepSeek is that DeepSeek wrote the code for NVIDIA's H800s in PTX. Now remember, again, PTX is a part of the CUDA ecosystem. It says so right here. It's been part of it from the beginning. We all understand that. Anybody who's used CUDA understands that, okay? But when they're doing this, they're writing it on a very low level, not the lowest level. Again, SAS is lower level, but they're writing at a very low level, okay? Which means that porting it becomes much harder. Now, you might wonder, why do they do this? Well, because if you go up higher to CUDA C, C++, the compiler there is going to not be as efficient as the PTX virtual machine. Thus, you get better performance by going down lower. Now the natural question is, well, why wouldn't you just write it in SAS and you would get the best performance? Well, yes, you absolutely would if you could master SAS. However, the difficulty of programming in such a low language and the fact that you would have to program for each and every separate architecture more than kills any minimal gains in programming, and the gains of execution that you would get. It would just destroy it because you'd be wasting all your time having to be very specific for everything. You'd be rewriting all this stuff. So PTX is probably the best place to go if you want to do something like that. Okay. Now that explains the PTX issue with DeepSeek and the fact that, when people say, hey, they didn't program in CUDA, they programmed in PTX, that's an incorrect statement. The correct statement would be, hey, they didn't program it in CUDA C++, they programmed it in PTX, or they programmed it in CUDA PTX, because again, PTX is part of CUDA. But CUDA extends beyond that too, right? CUDA has all these things in its tools and ecosystem. Has GPU accelerated libraries, debugging solutions, even includes accelerated web services directly from NVIDIA, cluster management, data center tools, languages APIs, performance analysis tools, and key technologies. Okay, so this is where I'm trying to show you that all of these things have been developed over literally 20 years to work cohesively together and form this powerful ecosystem where when I run into problems, I probably can go find a library, a tool, or a solution within this entire CUDA ecosystem to help me solve my issue. And that is the power of it, okay? And so in the AI generated response, it said PTX is proprietary, and it kind of was indicating that the rest of CUDA isn't. That's not true. All of CUDA, well, virtually all of it, you can use some open source libraries that interact with it, but all of CUDA is proprietary. Okay, NVIDIA owns it. This is closed source material. I'm not going to get into open source versus closed source, but one of the benefits of closed source is that over time, for your hardware, if you control the hardware, you can get deep and tight integrations. Now, I'm going to give you an example of this. I don't use iOS. I use Android, but typically iOS phones, relative to the size of the battery, get better performance than Android phones. And the reason for that, again, relative to the size of the battery, what Android does is it typically goes in and it boosts the size of the battery. Now, I'm not saying it's this huge gains, and you're going to say, wait, I know Android phones that beat iPhone. That's not what I'm saying. I'm not saying there isn't Android phones that can beat iPhone in total length. What I'm saying is relative to the size of the battery, typically iPhones do better. And that's because they're in a closed ecosystem. They don't have to worry about maintaining their code for architectures or different types of phones that they aren't familiar with, okay, which Android does. Android is an open source platform. So when they program it for it, they have to look out for different types of materials that they may not be using. Where iOS is, hey, we control everything from top to bottom. Now, you might think that sounds like a good idea, but there are downfalls to it. And I know I just said I wasn't going to discuss open source versus closed source, but here we go. The problem with it is that for your consumers, you generate something. Well, this might actually be a good thing too, in a way, for the company. You generate extreme lock-in, because if I'm using iOS, if I'm using CUDA and I want to leave, I can't take my toys home that I built with these and just go. Remember what I said earlier? That where someone said PTX, is more portable than CUDA C++? That's not necessarily true. Okay, CUDA C++ is not compilable on any other platform. You need the CUDA compiler, and that is proprietary. It's the same thing with iOS and the stuff they build for their development tools. However, for Android and in open ecosystems, what you can do is, if you don't like what they're doing, you can simply fork it and build your own version. Now, we've seen many Chinese companies do this with Android, and we've even seen a company in America, actually two companies do this. One, we've seen Microsoft do this with Android, and we've also seen Amazon. Their popular Fire tablets are powered by Android. And all Amazon said is, we don't want to be too much under the control of Google, but we love what they're doing with Android. Since it's open, we're just going to fork it at this point. We're going to pull down some of the changes that we like that they pull down, but we're going to control the direction of it ourselves. Okay. And that's the beauty of open source, is it gives you more choice. It gives you more control. And people tend to like open source. Now, when it comes to consumers that don't know about it, it doesn't matter to them. But when it comes to people that are in the know and understand, usually the preference, I would say, and this might be my bias, is for open source. Okay, simply because if you want to, you can take your toys home and leave with them. Now, someone might shoot in, well, there's these certain licenses. Yes, there's different licenses. We're not going to get into that today. But again, that's where, because of this fact that people can kind of keep their own work, or they can have a little bit more creativity with open source, you will have more people contribute back to it, which is why Huawei, and they're trying to accelerate catching up to NVIDIA. And so what they're doing is they're open sourcing their ecosystem in the hopes that they will be able to catch up to NVIDIA. Okay, so again, now we're going to go into this stuff. We have the CUDA toolkit. Okay, I just want to show you different aspects of CUDA. I'm not going to get deep down into these things. Okay, but what does a toolkit include? This is your typical software development toolkit. This would be the version of it for a GPU. What we use on like x86 or ARM would be the same kind of tools for those types of processors. Includes the GPU accelerated libraries, debugging and optimization tools. Debugging, optimization tools, kind of the basics that everybody needs to start off with. A C++ compiler, again, I was calling this the CUDA compiler, and a runtime library. And even me calling this a CUDA compiler is a bad name, because technically there's other CUDA compilers. I should call it a CUDA C++ compiler and other runtime libraries, okay? Then we come over here. We're going to go back to here. And I want to show you that even NVIDIA themselves, because like right here, where they have to explain CUDA extends, right? Because CUDA is well known to just be the toolkit in the C++. So even they, when they're talking about it, an even easier introduction to CUDA, this isn't about the CUDA ecosystem, even though they clear it up in the beginning here. It's about the programming model, i.e. CUDA C++. Okay, so even they will interchange the use of this term, and I want you to understand that. On this channel, when I talk about this, what I'm talking about is the CUDA ecosystem, okay? I'm not talking about the specific language. I'm talking about all these things like this, the CUDA compiler driver and VCC, right? I'm talking about the CUDA math libraries. See this? CUDA BLAS. BLAS is a very common open source, basic linear algebra. Many people have different implementations of this. But what did NVIDIA did? They went and made a CUDA proprietary version of this, right? Same thing with FFT, fast Fourier transformations, QRAN. These are all things that they use in the scientific community. Okay. But they built this tool set out there and they brought kind of law and order to it when it was the wild, wild west. And because of that, this is all proprietary now. They have a leg up on everybody else, including Google, including Huawei, when it comes to the CUDA ecosystem. So hopefully that makes sense. From now on, when you hear me talking about this, and when you hear Jensen Huang talk about if America wanted to win this, they need to get the rest of the world to build on our software stacks, on our protocol. He's talking about this, the CUDA ecosystem. And why is he talking about this? Well, one, because he owns, or doesn't own, but he's the CEO of NVIDIA. And two, because NVIDIA, an American country, controls the direction of this software stack because it's not open source. Okay, so we can directly influence the control and the direction of this software stack. Now, understand with Android, right? You might say, well, that's interesting with Android because it got cut off. Well, technically, Android did not get cut off from China. Huawei could still use Android, but they couldn't use what Google did is they have Android, the open source version, and then they include these very important tools and their proprietary tools. And Huawei realized that without these Google tools to go with Android, there was a lot of hassle and it was probably just better to start from the ground up. And you might say, well, why didn't Amazon do that? Well, Amazon doesn't make phones, they make tablets, and a lot of these Google mobility services are related to cell phones, i.e. the proprietary drivers are in all of these cell phones that we use. Cell phones are extremely complicated. And there's a lot of patented software everywhere in them, okay? Just so you know. So even, sorry, what was my tangent there? I got off a little bit. So I just kept bringing that up because I want to explain with Android, because you might have like made the connection and said, wait a second, well, if Android's open, why can't Huawei use it? Technically, Huawei could. They could. But the most important, not the most important, but very, very critical parts of Android are proprietary for cell phones. And Huawei was like, well, instead of us having to go around this, we're just going to use or create our own open harmony system, which is what they did. Now, Huawei, just so you know, right, they were also cut off from ARM. Okay, so they are stuck on ISA 8. ISA 8 is proprietary, but they had paid for it in full, so you can't take that away from them. Even the U.S. can't take that away from them. How are we going to take it away from them if we wanted to anyways? What are we going to do, pry it out of their hands? I wouldn't put it beyond Pete Hegseth to try that. Maniacs in Washington, they would try that, but it would be absolutely ridiculous. But ARM, unfortunately, cannot license their ISA 9, V9 to Huawei. Okay, so what is ISA V9? Well, it's just basically, it's probably more similar to the PTX, what I was talking about there. I don't want to get too technical. It's just a very low instruction set architecture, right? And so the newest version of it, they're not even allowed under export controls to license that to Huawei. And because Huawei, right, can't license it, they don't know what it is, they can't use it, they're stuck on 8, or they would have to come up with their own new architecture to replace that. Okay, so hopefully this is starting to make sense how these chip wars work and how this stuff goes. And so that's what Jensen's saying, right? And that's why he's kind of pointing out, is he's saying, hey, look at what's going on here. You cut them off from Android, so they built Harmony. We have cut them off from our instruction, our ISAs. Now they've kind of built their own. Understand that Huawei's Ascend accelerators are built on an ISA instruction set architecture that is nothing like NVIDIA's at all. It's a homegrown instruction set architecture, right? And what he's saying is, if we want, we don't want them to build their own alternative things. If you wanted to win, you would have them using our systems. Because again, when they use our systems, then we control what's going on. Look what happened with ASML. ASML sold China this hardware for lithography. And then the US came, Trump, and sanctioned Huawei and sanctioned China and said, ASML, you cannot even service the contracts you have. And so Huawei and China was left with, they're out billions of dollars because of that, right? And that is the power. And ASML is out billions of dollars. Trust me, ASML CEO has complained many times. He's like, this isn't our trade war. This isn't our sanction war. Why are we being affected by this? I'm paraphrasing. He can't say it directly because then the US would probably arrest him. But anyways, so that's why Jensen's saying this about CUDA. CUDA is closed. It's closed. If we got people, imagine that you get Iranian companies using CUDA. Imagine that you get Russia. Imagine that you get China, right? Then what we can do is once they're dependent on it, right? You could say, hey, if you cross us, just like with the SWIFT system, we're going to put sanctions on you. How? We're going to sanction you through software, through CUDA. You're not getting the updates necessary to maintain your ecosystem. Okay, you're stuck on this version. You don't get any of the software fixes, updates, patches, whatever coming through. That's how you would sanction them, right? Plus, they would be using our protocols. What does he mean by that? The protocols that would be set forth would be the ones that we develop, we control, and we set, which is super important. It's not like you could sanction them through that, but it's that you control the direction of where everyone's going, and so you can predict where they will be. Okay? So hopefully this 101 broke everything down. So when you go in the comments and I say that and you say, oh, this is interesting about CUDA, and someone comes in and says, no, it's not CUDA, it's PTX. Understand that that's not a wrong statement, but it's also not a right statement. CUDA is an ecosystem. It's not something in particular. Okay? All these libraries up on your, or that were up on the screen, CBLAS, CFFT, CURAND, those are all a part of CUDA. Okay, so are you talking about that? Are you talking about CUDA C++? Are you talking about CUDA PTX? What are you talking about? I'm just referring to CUDA as the ecosystem. This is the advantage that NVIDIA has. This is what Jensen's talking about. So also, to be clear, I'm not saying that hardware is not important. I want to be clear because a couple people in the comments kind of called me out. They're like, hardware is important. Hardware absolutely is important. What I'm trying to emphasize is the fact that as long as you are within a couple generations, so I would say, let's say it, this is just purely my opinion. As long as you're within 1.5 generations, okay, then hardware becomes less important than software. Okay. And we know this from Google's chip, right? Because if that wasn't true, everybody would be flocking over to Google Cloud. And they are. A lot of people are going. So you might say, wait a second, Google Cloud's growing. They got this huge backlog. Yes, they are. They are. I mean, literally everyone would be knocking on the door because their chips are so much better than even NVIDIA. Okay, blows it out of the water. But the simple fact is that they don't even have an ecosystem to match Huawei's, and Huawei's system is in its infancy. Okay, and that's typical Google. That's how Google always does stuff. That's one of the things as a stockholder, I always get frustrated with Google. It's like, come on, guys, you have to build and maintain the tools, right? So anyways, that's what I got for you today. Hopefully it all makes sense. CUDA is many, many things, okay? But the most important thing that it is that you understand in these chip wars is that it's a proprietary ecosystem. Okay. Now, again, someone might come and say, well, there's this one open source library. I'm not saying the entire 100%. Okay. But the majority of it is under NVIDIA's control and direction. It's proprietary, is not transferable. So again, if someone's telling you, oh yeah, CUDA C++ would be more transferable. Well, technically is it more, but it's really not transferable. Okay. Because again, I already went into it. The compiler and everything is different and different. So Once you get people into CUDA, it doesn't matter what they are using. They could be using CUFFT, they could be using CUDA C++, they could be using CUDA SAS, whatever you're using in CUDA. Once they're in it, you have a hook in them. You got some hooks in them. And what it does then is like, oh, you got a problem with whatever you did. Here's another tool, right? Here's a CUDN, right? Use that to solve your tool. Oh, I got another hook in you. Oh, you got this other hook in you. You know, here's this other tool and a CU tensor. Use that, right? Oh, we got CUX. Use that, right? So all of a sudden, you got all these hooks in you. And you're like, my God, I can't pull away. I can't. Oh, I got to rip off all my flash to get away. Okay, hopefully that makes sense. If this was a terrible video, let me know down below. I hate when I go into detail like this because I could go on for hours. I really could. But anyways, hopefully that makes more sense. Thank you very much.